Good morning, guys. In the last session, we completed our discussion related to JWT token. How do we secure our REST API by using JWT, and how can we access that secured REST API by using client API? So server and client we develop. Client application will send the request to the server with the authentication data. If the credentials are authenticated, then we will get the response from the server with the token. Once we get the token, client will send second request along with the token. The token will be validated by the server. If the token is valid, then we will get the response from the server. So we have completed that. Are you guys able to practice that JWT server client application? Are you guys able to practice JWT server and client application? Good. So today we are going to start with one more topic, which is called SAGA design pattern. We are going to talk about one concept called SAGA design pattern. Okay, what is this SAGA design pattern and why we need to go for this SAGA design pattern? Let us first check here what is SAGA design pattern in microservices. So there are n number of links are available. Microservice architecture patterns SAGA. So what is the problem with the existing approach and what is the solution that we are going to get by using SAGA, right? SAGA design pattern. So you see here, they have given some information related to what is a SAGA. SAGA pattern is a design pattern used in the microservices architecture to manage complex transactions that involve multiple services. Okay, so we are talking about microservices. We created several microservices. In the microservices architecture, each service is responsible for its own data and performs some business function. So when we are talking about microservices architecture, our project will be implemented by using multiple services. For example, here, user service is available. User service is available. This user service will deal with user registration and user login in our system. Once it is completed, then user want to purchase some products. So there will be products service, products catalog service will be available. Catalog service will be available, which will display all the products which are available in our application. Then after, we will be having one more service called order service, which will deal with the user orders information. When user want to purchase some product, so they will place the order. Order service will deal with that. Then next one, there will be a service called payment service will be available. There will be a service called payment service will be available, which will deal with the user payment process for the order that they are trying to purchase. Once the payment service is done, then we will be dealing with delivery service. So it will deal with the product delivery to the customer. So this is one e-commerce application. If you take that scenario, okay, and delivery service will be available. Then here tracking service also will be available. Okay, so here tracking service will be available. So user will be checking once we place one order for every 1 day or for every half day, the users are going to check the status of their order. What is the status? Where is that delivery item currently? When it will be reaching to the end user? So the tracking service will provide that information. So in our application, multiple services will be available like this. So these are called as microservices. So microservices, nothing but independently deployable services. And every microservice will have its own data, and every microservice is responsible to perform some operation. That is what they're saying here. SAGA is a design pattern used in the microservices architecture to manage complex transactions that involve multiple services. So in our application, multiple services will be involved. In our application, multiple services will be involved. and every service will maintain its own data, and every service is responsible to perform some operation. Okay. Now, when these many services are available, so when user want to purchase some order, first user will log in into our system. When the user log in into our system, then user will go to catalog service, and user will select what are the products which are available in the system, in the application. From the catalog, he will select the product and he will place the order. Once he places the order, then from the order, we need to go for payment option. Once the order is placed, then it should ask for the payment. Payment service comes into picture. So if the payment is successful, then only order should be confirmed. If the payment is failure, then order should not be confirmed. So that means there is some relation between the order and the payment. If the payment is successful, then order should be confirmed. Then it should trigger delivery service. When the delivery service is started, the delivery process, it should trigger tracking service. So here, all these microservices are interconnected to handle one order purchase. So all these microservices are involved in one order purchase. Suppose if you don't develop this project using microservices architecture, everything will be available in one project. Okay, user will be available, catalog will be available, order will be available, payment will be available, delivery will be available, tracking will be available. So if we manage everything in one application, that one application will maintain one database. If you go for monolithic application, then tables will be available, DB will be available. Okay. Now, so when user places the order will be created, payment will happen. If the payment is failure, then we can commit the transaction. If the payment is successful, then order will be committed. If the payment is failed, then we will roll back the order. So transaction commit, transaction rollback we can do, because this is one single application. In one single application, tables will be available. So we can place the order, we can take the payment. If the payment is successful, then order will be placed successfully. If the payment is failure, order will be rolled back. If you have one database, that is okay. If you have one database, easily you can manage the transactions. So if you have one database, then what will happen? So here, our application is available. So we will be having orders table. And we will be having payments table. Orders table, payments table will be available. Okay. So now, when user places the order, the record will be inserted into orders table. When user places the order, record will go to orders table. Okay. Then user will go for the payment. When the order is done, user will go for the payment. If the payment is successful, then order will be successful. If a payment is failure, then order will be deleted. Okay. If a payment is successful, order will be successful. If the payment is failure, order will be failed. So this we can easily manage. This kind of transactions we can easily manage when our application is developed by using monolithic architecture. Because if payment is a success, then commit the order. If a payment is failure, then roll back the order. Because both the tables are available in the single database. If payment is success, then what we need to do? If a payment is success, then we need to commit transaction. Okay. Else, then we need to roll back the transaction. So this logic we can implement in order to manage transactions in our project. It is very simple and it is straightforward. Are you guys able to follow this? So you don't need to discuss much about this concept. The reason is monolithic application, only one database is available. There are two tables available. User will place the order will be created. Once the order is created, then user will be redirected to the payment page. If user payment is success, transaction will be committed. If user payment is failed, transaction will be rolled back. That means order also will be rolled back. Okay, but nowadays people are not developing the application by using monolithic architecture. Monolithic architecture is a outdated process. Monolithic architecture is a outdated process. Now, currently in the market, people are following microservices architecture. When you go for microservices architecture, every microservice is having its own database. Every microservice is having its own database, and every microservice is having its own data. Order placing will be taken care by one microservice in one database. Payment processing will be taken care by another microservice in the another database table. Okay, guys. Are you getting my point? What I'm trying to explain now? If you are using monolithic application, single database will be available. All the tables will be available in the one database. So order will be created, payment will process will happen. If a payment is successful, commit the transaction. Order will be placed. If the payment is failed, roll back the transaction. Order will be deleted. But the thing is, here we are not going with monolithic architecture application. We are going with a microservices architecture application. When you go for microservices architecture application, there are multiple services available. Now, order service is having orders database. Okay, orders will have a separate database. Orders will be placed into orders table. Then payments will have a separate database. This is called payments DB. Payments having a separate database called payments DB. Now, okay, so first user will place the order. Order will be created in the order database. Then user will go to the payment. Then payments will be maintained in the payments database. If a payment is successful, then only order should be successful. If the payment is a failure, then order should be failed. But they are in the same database. Orders information, payment information maintained in the same database. Orders information, payment information not in the same database. They are not in the same database. Then how do you handle a transaction between orders and payments? This is the problem in the project. If it is a monolithic application, straightforward. Either commit or roll back based on the payment status. But here, orders will be taken care by one microservice, payments will be taken care by another microservice. If a payment is successful, then only order should be confirmed. If the payment is failure, then order should be cancelled. But these are two different microservices and maintaining two different databases. When we have different microservices to do this order processing, how do you manage the transactions? It will become very difficult to handle this scenario. To overcome this problem, SAGA design pattern came into picture. What is that SAGA design pattern? SAGA design pattern is used in the microservices architecture to manage complex transactions that involve in multiple services. So when the request is processing by multiple services, then managing the transactions will become difficult. Okay, so in order to simplify this transaction management across the multiple microservices, we are going to use SAGA design pattern in the project. Now you got the basic idea why we are going for SAGA design pattern, what problem the SAGA design pattern is going to solve. Guys, now you understand what is the problem in the industry and what problem is there in the industry and what SAGA is doing for them. Okay, SAGA is one design pattern which is used to deal with the long-lived transactions which are involved in multiple services. Okay, so by using this SAGA design pattern, we can manage complex transactions involved in the multiple microservices in the architecture. So in the multiple microservices are there, each microservice will have its own database. Every microservice is responsible for its own operation. Okay, so when multiple microservices are involved here, then how do you manage the transaction? So order is created. Order is stored in the orders database. When the order is already created, then we are going for the payment. Then the payment may be successful or payment may be failed. So first the user selected the product in the catalog, user placed that order, user add purchased that, then order is created, then we will go to the payment. Payment will be maintained in the payment database. If the payment is successful, then order should be successful by order service. If the payment is failure, order should be cancelled by the order service. That means payment service, what operation is doing, that response of the payment service required for the order service to perform or to come to confirm the order or to cancel the order. Okay, managing the transaction with the multiple microservices is a difficult process. So to overcome that difficulty, we are using SAGA design pattern. Okay, so here my transaction, either commit the order or roll back the order, depends on the payment that we are using. So here the transaction requires coordination between multiple services, which can be challenging to manage. SAGA is a design pattern that is used in microservices architecture to manage complex transactions that involve multiple services. Right? Multiple services are there. User service, catalog service, order service, payment service, delivery service, tracking service. And every microservice is responsible for its own data. Every microservice will maintain its own database and they will perform specific business operation. Okay, so in this kind of microservices, in this process, the transactions requires coordination between the services. That will be difficult to manage. Okay, so in order to manage the transaction among the multiple microservices, we are going to SAGA pattern. SAGA pattern will break the complex transaction into smaller individual transactions which are handled by different microservices. Okay, so each individual transaction executed in order and the results are stored in a central repository. First microservice performed one transaction, then second microservice performed one transaction. Based on the second service transaction, we need to decide whether we need to commit the first transaction or we need to roll back the first transaction. So when we have the large complex transactions which are involved in multiple services, then we need to go for SAGA pattern to manage the distributed transaction. So earlier in the monolith, transaction at one place, but now transaction at multiple microservices. So to handle the distributed transactions in the application, we are going for SAGA design pattern. SAGA nothing but SAGA of transaction, nothing but sequence of transactions. SAGA means sequence. Sequence of transactions will be available. Multiple services are involved. So here, each transaction will update in the single service and coordinate with the other services which are available in the microservices project. Okay. Now, what this SAGA is going to do? SAGA will maintain its local transaction for every service and it will update all the transactions in the central repository. One central repository will be available in order to manage the distributed transactions in the application. And when you are going for the SAGA transactions, SAGA design pattern transactions are divided into two types. One is choreography based SAGA design pattern. Second one is orchestration based SAGA design pattern. So choreography SAGA design pattern nothing but there is no central coordinator or controller to manage the transaction. It is going to work based on the events. So SAGA design pattern is used to manage distributed transactions. What is this SAGA? It is a design pattern. It is a design pattern to manage complex transactions in microservices. Okay. In microservices architecture, multiple services will be involved. Multiple services will be involved. Every service will maintain its own data and every service is responsible to perform specific operation. Okay. Now, so example, order service will place order. Payment service will process payment. Will process payment. So here order confirmation depends on the payment process. First, user will place order. User will place order and will proceed for payment. User will place order, will proceed for payment. If payment is successful, then order should be confirmed. Else, order should be cancelled. Order should be failed. Okay. So here coordination is required between order service and payment service. So in order to complete user request, coordination is required between above two services. Coordination required between above two services. Two services are using two different databases. As these two services using two different databases, managing transaction, commit and rollback is very challenging. You understand the problem? Multiple services will be available in the architecture. Every service will maintain its own database and every service is responsible for its own functionality. When multiple services are involved, managing the transaction is very difficult. So we can simplify these transactions. As two services involved in the operation, this is called distributed transaction. As these two services using two different databases, managing transaction commit and rollback is very challenging. Okay, so this is we need to implement distributed transaction to handle this scenario. Okay, SAGA design pattern is used to simplify distributed transaction management in the application. What is that? SAGA design pattern. SAGA design pattern is used to manage distributed transactions in the application. So we need to implement distributed transaction to handle this scenario. SAGA design pattern is used to manage distributed transactions in the application. Okay, right. So SAGA means SAGA transaction, nothing but SAGA transactions means sequence of transactions. SAGA transactions, nothing but sequence of transactions. SAGA pattern is used to simplify distributed transactions in the microservices architecture. Are you guys clear? SAGA is used to simplify distributed transaction management in the microservices based applications. SAGA pattern is used to simplify distributed transaction management in microservices architecture. Okay, SAGA pattern divided into two types. SAGA pattern we can implement in two ways. SAGA pattern we can implement in two ways. What is the first one? The first one is choreography pattern. Choreography SAGA. Second one is orchestration based SAGA. Choreography and orchestration, these are the two ways that we can follow, implement SAGA design pattern, which is used to manage distributed transactions. Can you read this one? What is choreography based SAGA and what is orchestration based SAGA? Could you please read these 2 points? SAGA pattern can be implemented in two ways. One is choreography based SAGA pattern. Second one is orchestration based SAGA pattern. Could you please read that? Guys, are you reading this? In a choreography-based SAGA pattern, each service in the transaction communicates with the other services directly to coordinate their actions. In choreography-based SAGA pattern, each service in the transaction communicates with the other service directly to coordinate their actions. There is no central coordinator to control, to manage, central coordinator or controller to manage the transaction. So here there is no coordinator to manage the transactions when you go for choreography based SAGA pattern. Instead of this central coordinator, each service will publish event to notify other service of its actions and subscribers to events to receive notifications from the other services. This way, each service knows what action to take based on the events it received from the other services. Choreography based pattern is called as event based pattern. We will manage the transactions among multiple microservices based on the events. Okay, one service will perform some operation, will trigger one event. Based on the trigger, the other service will take the event based approach we are going to follow. Now, see the second one. Choreography means you understand. Event will be available. So like Apache Kafka, they will use one message queue and one application will publish the message to the message queue. Another application will receive the message from the message queue. Like that, we can implement event-based transaction by using choreography pattern. What is the next approach is available? The next approach is orchestration-based SAGA pattern. So can you read what is orchestration-based SAGA pattern? In orchestration-based SAGA pattern, a central coordinator or controller service manage the transaction. Coordinator send a message to each service to instruct it on what action to take and in what order. The coordinator is responsible for managing the flow of the transaction and coordinating the execution of each stage in the SAGA. So a separate microservice will be acting as a coordinator here. A separate microservice will be acting as a coordinator here. Based on that coordinator, the services will decide what operation they need to perform. Choreography based SAGA pattern, orchestration based SAGA pattern. So let us see how they are going to be different. So here I have order service. Here I am having order service. So this order service will have its own database. As I told you, every microservice will have its own data and every microservice responsible for its own operation. Order service is connected to orders DB. Order service is connected to orders DB. Here, payment service is available. Here, payment service is available. It will maintain its own DB. Payments DB. Payment service is available. It is maintained by its own database. Payment service maintains its own database. Now, user will place the order. Okay, so these are distributed applications. Order service is one microservice running in the separate server, communicating with its own database. Payment service is a separate microservice connected with the payments DB. These two microservices are responsible. The coordination is required between these two services to perform the operation. Coordination is required between the two services to perform the operation. So here I'm going for choreography based transaction, right? Choreography based SAGA pattern I want to implement. Okay, choreography based SAGA. When you go for choreography based SAGA, we need a message queue. When you go for choreography based SAGA, we need a message queue. So I'm going to use Apache Kafka as a message queue. We already discussed what is Apache Kafka and why we need to go for Apache Kafka. Okay, so we need to understand what is Apache Kafka. Okay, right? So Apache Kafka will be available. So what is Apache Kafka? Apache Kafka is a message queue where we can store messages of our application. Then whenever a order comes from the user service. Whenever the order comes, here user service will be available. User is going to place the order in our application. User will place the order in our application. Whenever the order is placed, the order service will publish one event to the message queue. It will publish one event to the message queue. Okay, right. Once the order is placed, the order will be stored into orders DB. What products you purchase, what products you have selected, what products you have purchased, what products you want to purchase, the order will be available. That order will be created in the orders database. Then order placed, that message will come to Apache Kafka. That is a message queue. One event will be triggered. Whenever the message is triggered for the message queue, then immediately that will be received by payment service. Payment service will receive that event. Okay, order is placed. Then immediately payment should happen. Then payment process will start. Payment service will pitch in and payment service will do the payment processing for the user. When the payment processing completed, it may be successful or it may be failure. When the payment is successful or when the payment is failure, it will publish one message to the Kafka topic. Yes, I have received the payment successfully for the given order. When the payment is received successfully, payment service will publish one event. Payment service will publish one message. When the payment service publish this message, then order service will receive that message and will confirm the order. Okay, so now here it will subscribe to the message which is given by the payment service. Payment service is payment service, order service, two different projects running in the two different servers using two different databases. But we need coordination. For that coordination, we are using Kafka as a mediator, as a messaging queue. So events, message will be published. So first order will be available. Whenever the order is placed, order service will publish one message to the Apache Kafka. Orders topic will be available. When the message published to the orders topic, then payment service will subscribe to that message and it will do the payment processing. When the payment is successful, it may be failure or it may be successful, then it will publish one event to the payment service. It will publish one message to the payment service. When the message is published to the payment, order service will subscribe to that message, will check the payment is successful or failure. If the payment is successful, then the order will be confirmed. If the payment is failure, the order will be failed. So the transaction will be managed into different applications. So this is long-lived transaction. When user places the order, till the payment completion, order confirmation, the transaction will be long-running transaction. Okay, so this long-running transaction we can manage by using message queue based on the events. One service will publish an event, another service will subscribe to that event and will follow the next step. Okay, so order will be placed by the user, then one event will be triggered, will publish a message to the Kafka topic. When the message stored in the Kafka topic, subscriber will subscribe, payment service will subscribe to that message, okay, order is placed, then payment should happen. The payment processing will happen. Payment, if it is successful, publish a message. If it is a failure, publish a failure message. If it is successful, publish a successful message. Based on the message published by the payment service, order service will subscribe, order service will decide whether to confirm the order, whether to fail the order. So here, this is called choreography-based SAGA pattern. So in order to manage distributed transaction, we are using this choreography-based transaction. We are using choreography-based transaction. Are you guys clear with my point? Are you guys clear with my point? How the distributed transactions will be managed? Come on. What is a SAGA? SAGA is a design pattern which is used in the microservices architecture to manage complex transactions that involve multiple services. In the microservices architecture, as we discussed, multiple services will be available to perform the operation. Every microservice is responsible to perform some operation. Every microservice will maintain its own table and will perform a separate action. If you develop this e-commerce application with the monolithic architecture, we no need to think like this. The reason, everything will be maintained in one database, right? So insert the record into one table for the orders. When the order is placed, store the order data into order table, then start the payment processing. If the payment is successful, then confirm the order or else roll back the order. That is very simple in the monolith. But when it comes to microservices, right? Orders is one service running in the separate server. It will maintain its own database. Okay. And payments will be available in a separate service. It will be maintained its own database. First, order will be confirmed, order will be placed, then payment will start. If the payment is success, then order should be confirmed. If the payment is failure, order should be failed. So there should be some coordination between the services that we are implementing in the project. So when we are implementing these multiple services to handle a single request, coordination is required. So here the long running transaction will be available. So till the payment service completed and order is confirmed, we will call it as a single transaction, but that will span across multiple services. That will span across multiple microservices. That's why this is called distributed transaction. So this distributed transaction management, we will do that by using SAGA design pattern. SAGA pattern, nothing but sequence of transaction. Order service will have a local transaction. Payment service will have a local transaction. But in the application point of view, the two services involved in one request processing. One user want to purchase some product. He will place the order, he will do the payment, then confirm the order, then deliver the order. Okay. So this kind of operation we can manage by using SAGA design pattern. When we go for this SAGA design pattern, we can implement this SAGA pattern in two ways. So what are the two ways? One is choreography based SAGA pattern and the second one is orchestration based SAGA pattern. So when you go for choreography based SAGA pattern, this is called event based pattern. When you go for orchestration pattern, it is called command based pattern or controller based pattern. Choreography based pattern, SAGA pattern, we can implement SAGA pattern in two ways. One is called choreography based SAGA pattern and the second one is orchestration based SAGA pattern. When you go for choreography SAGA pattern, as we discussed here, that choreography based pattern will implement in the event driven approach. So in this pattern, each service in the transaction communicates with the other service directly to coordinate their action. There is no central coordinator here, but the controller to manage the transaction. Each service will publish events to notify other service of its action. As we discussed, when the order is placed, it will publish one event to the queue. A message queue will be available. It can be ActiveMQ, RabbitMQ, or Kafka. Currently, people are using Kafka as a message queue. So when the operation completed in one service, it will publish one event to the queue. Then subscriber will subscribe to that event and will perform the operation. So you see here, each service publish events to notify other service of its actions and subscribers to the events to receive the notification from the service. This way, each service knows what action to take based on the events it received from the service. Now, once the payment is completed, payment service will publish a event. Payment service will publish a event. Based on the event, order service will take a decision whether to confirm the order or whether to fail the order. So one service will publish the event based on the action. Another service will subscribe to that event and will take the decision what to do next based on the event received. If a payment is successful, it will publish success event. Then order service will receive that success event, will subscribe to that success event and will confirm the order. If the payment service is failed, right? If the payment is failed, it will publish a failure event to the Kafka. If it is a failure event, other service will subscribe to that event and it will fail the order. Payment failure. So two services will coordinate by using event-based approach. This is choreography-based SAGA pattern. This is choreography based SAGA pattern. Are you guys clear? What is the SAGA and what is choreography based SAGA? So we have already seen Kafka, right? So in the same way, we are going to that's we already seen how to publish one message and how to subscribe to that message. So now after publishing the message, that will be subscribed by subscriber. Subscriber will subscribe to that message. Based on the message received by the subscriber, it will take the next action, either to confirm the order or to fail the order. So this is choreography based SAGA. Then what about orchestration based SAGA? Can you please read this? Choreography based SAGA, then what is orchestration based SAGA? In orchestration based SAGA pattern, a central coordinator or controller service manages the transaction. That means queue will not be available. There will be a separate microservice which will decide what to do next. What is the flow of execution will be decided by another service. That is called command service or coordinator service or controller service. Orchestration based. Orchestration nothing but management. So in your projects, some orchestration teams will be available. So here, orchestration based SAGA is different. Orchestration team is different. Orchestration means basically management. DevOps teams will do that orchestration for the Docker container by using Kubernetes. So if you see orchestration team in the project, nothing but Kubernetes team. That Kubernetes team will manage our Docker containers. Orchestration means basically management. So orchestration based SAGA is different. Kubernetes orchestration is different. There is no relation. Kubernetes is used to manage the Docker containers. So they will take care of the application deployment. They will manage application execution with the Kubernetes platform. That is orchestration team. But here, microservices orchestration pattern nothing but which will manage transactions in the multiple microservices, which is used to manage distributed transactions in the microservices architecture based application. Are you guys clear with my point? Orchestration nothing but management. Choreography means events. Choreography nothing but events. Orchestration nothing but management. Now, how this orchestration based SAGA is going to work? How this orchestration based SAGA is going to work? Now, see here. I have order service as we discussed. Order service. And I have payment service. Order service will have its own database. Payment service also having its own database. Okay. Now, how do we manage the transaction between these two services? How do we manage transaction between these two services? To manage transaction between these two services, there will be a orchestrator service, another microservice. There will be a orchestrator service will be available. Now, this orchestrator service will be managing these two microservices. First, order will be placed. User is going to place the order. When the order is placed, then that will be when the order is received, then orchestrator will be sending that, okay, order, you take the order and you keep in the database. Once the order is completed, then it will give to the orchestrator a payment, you take the payment. Once the payment is successful, then orchestrator will tell, hey, order, you confirm that. If the payment is failed, hey, order, you cancel that, you fail that. So here, a coordinator will be available, that is called orchestrator. A coordinator will be available, that is orchestrator. So orchestrator nothing but management. Orchestrator nothing but management. Choreography based SAGA, orchestration based SAGA. So as they are telling that both are having its own advantages and disadvantages. Choreography based and orchestration based SAGA patterns are having their own advantages and disadvantages. Choreography based SAGA patterns are more decentralized as there is no central coordinator and service can act independently, making the system more scalable. However, it can be more complex to manage and debug as it can be difficult to determine the order of events which service is responsible for which action. Orchestration based SAGA, more centralized. Everything is easy to manage because there is a coordinator. Coordinator will tell what to do next. It can be less flexible. Transaction requires changes to the coordinator. It can become bottleneck as the system scale. So if your system is scaling, if you are having a large complex system, better to go for choreography because so it will be managed by the Kafka. And if it is a small scale system, then orchestrator will manage everything. When the complexity is increasing, when the number of services are increasing, always we need to keep updating our orchestrator service. So it depends on the requirement, we can decide whether to go for choreography or orchestrator. If it is a large scale system, then better to go for choreography. If it is a small scale system, go for orchestrator. So both choreography and orchestrator having its own advantages and disadvantages. Are you guys clear with my point? Read that. Which one is recommended? Choreography is recommended or orchestration is recommended? Choreography is recommended or orchestration is recommended? You read it. When to go for choreography and when to go for orchestration based SAGA. Choreography based orchestration, choreography based and orchestration based SAGA patterns are having their own advantages and disadvantages. Choreography based SAGA patterns are more decentralized as there is no central coordinate and services can act independently. We can make our system more scalable. We can keep on increasing our functionalities also. Right. Orchestration based SAGAs are more centralized because a coordinator is going to manage everything what should happen in the system. Choreography based SAGA patterns are more decentralized. There is no coordinator to control the actions. Okay, there is no central coordinator. They can every service can work independently, making the system more scalable. However, it can be more complex to manage and debug as it can be difficult to determine the order of events which service is responsible for which action. So every service can work independently. They can publish the event, they can subscribe the event. There is no coordinator who will coordinate that work. But whereas if you go for orchestration based SAGA, this is more centralized because everything is controlled by coordinate, which makes it easy to manage and coordinate the transaction. But the flexibility is very less because whenever there is a change in the microservice system, then always we need to change our orchestrator also. Good. Choreography pattern. Order service is available. Whenever the order is coming, order will be saved in the database and it will publish a message to the Kafka top. We have already learned Apache Kafka, how to publish a message to the Kafka top. Order service is available, which will publish first whenever user send a request here. Whenever user places order, order service will save the order in the order database. After saving the order in the order database, it will publish one message to the Kafka topic. Kafka.send order is created with the order ID. Once the order is created, then inventory service will be available. So it is going to save that product in the inventory service. Okay. So once it is done, then the inventory service will publish that and payment process. Next logic we can execute. So order created. So it will be listening to that. Whenever the order is created, the inventory service will be listening to that. And here the payment also can be processed. Payment also can be processed by using Kafka listener. It can handle that. Okay. Now, so when you go for order service here, create order events, send the order events to that, then payment process is available. If the payment is successful, then payment process message will go to the Kafka. Once the payment is successful, order fulfillment service will be available. Take to that event, then payment is successful. Then if the payment is available, order is fulfilled. When the order is fulfilled, then payment process event fulfilled. Then order will be confirmed. So it's based on event. First you see order will be placed, save order is available. Once the order is saved, it is publishing one event to the Kafka. Then inventory service is available. It is listening to the order created event. Then it is getting the order information. What are the orders available? It will check each order in the inventory service. Once it is done, then it will go to order fulfillment service. It will send one message to the Kafka topic. Once it is created, payment service will listen to that, will do the payment processing. So once payment is successful, it will send payment processor successfully. Once payment is processed successfully, then it will publish a message. Okay, it will publish a message, payment processed successfully. Once it is published, then order fulfillment service, which will confirm the order. Once the order is confirmed, it will send to the delivery service. Okay, so it depends on scenario, right? First order is coming, order will be saved in the order database. When the order is saved in the order database, then it will send a message to the Kafka topic. Then inventory service or payment service will listen to that message and will do the payment processing. If the payment processing is successful, then it will publish payment processed message to the Kafka topic. Then it will be listened by order fulfillment service. Once the order fulfillment service is listening to that, then it will confirm the order. Otherwise, it will not confirm the order. Event-based implementation. Just like if you know Kafka, then easily you can implement this distributed transaction by using Kafka. That is choreography-based SAGA pattern. Choreography-based SAGA pattern. If you go for orchestration-based SAGA, there is no Kafka topic, something like that. Everything will be managed by a orchestrator. Another microservice will be created, which will decide what to do next. Okay, guys, good. SAGA design pattern. SAGA is a design pattern to manage complex transactions in microservices. In microservices architecture, multiple services will be involved. Every service will maintain its own data, and every service is responsible to perform some specific operation. Order service, payment service, and we can say order fulfill service. Will confirm or fail. First, user will place the order and will be proceed for payment. First, user will place the order and will proceed for payment. If payment is successful, then order should be confirmed, else order should be failed. So based on the payment event, order fulfill service, based on the payment, order fulfill service will take action. Order service, then payment service, then order fulfill service. Okay. SAGA pattern is used to manage distributed transactions in the microservices based application. So that SAGA transaction means sequence of transactions will be available. SAGA pattern is used to simplify distributed transaction management in the microservice architecture. SAGA pattern can be implemented in two ways. One is called choreography-based SAGA, orchestration-based SAGA. Choreography-based SAGA pattern will work based on the events. Okay. Choreography pattern works based on events. Okay. We will use message broker to publish and subscribe events. Choreography pattern working based on the events. So here we will use message broker like a Kafka to publish or to subscribe the events of our application. So as you have seen, the sample coding also they have given in the internet. First order will be created, then it will go to the inventory, then it will go to the payment, then it will go to payment order fulfill service. So first one, create the order. Once the order is created, it will be saved to the database. Then it will publish a message to the Kafka topic. Order is created with order ID. Okay. Then once the order is created, then it will go to inventory service. It will go to inventory service. Inventory service will be listening, update the inventory levels based on the order details. So whatever the order we have placed, we need to reduce the inventory information. We need to minus that inventory information in the store. Okay. Then update the inventory. Once the inventory is updated, then it will publish one message and it will just update the inventory. Then after payment will be triggered. So here order is saved. Order is saved, then it is going to create the event, order created. Based on the order created event, payment is going to trigger, payment process. Once the payment is processed successfully, it will trigger one event, payment processed. When the payment processing is completed, order fulfillment. It will be listening to the order events. Once the order is saved, then check the payment is available or not. Yes, payment is available. If the payment is available, then it will publish a message, payment saved, then it will publish a message saying that order fulfilled. Once the order is fulfilled, order is saved. Then it will be going to the delivery service. So one service will take the action, will publish the event to the another service. Another service will receive the event from the topic and will take the next action. If it is orchestration based, a command will be available, a central controller will be available in order to manage the transactions. This is distributed transaction management in the microservices. So to manage this, we are using best design patterns, that is SAGA design pattern. SAGA pattern can be implemented in two ways, choreography based pattern and orchestration based pattern. So tomorrow we are going to see how to implement choreography based SAGA pattern. Tomorrow we will see how to implement choreography based SAGA pattern. For that we need to have our Kafka up and running. Okay, so I will prepare a document today. So to implement that choreography based pattern, so I'm going to take three services, guys. One is order service, payment service, order fulfillment service. Okay, based on three microservices, we will implement SAGA pattern by using choreography approach, by using Apache Kafka as a message. Yeah, so we are good with this. So theoretically, we understood what is SAGA, why we need to go for SAGA. So tomorrow we are going to implement this SAGA pattern with choreography approach. Good, thank you. Anybody having any questions? You can unmute and you can ask me.
Yeah, good morning, Ashok.
Very good morning.
Ashok, generally when we go for the OAuth2 and JWT, OAuth2 is for third party.
OAuth2 and JWT means, so if you want to implement the third party login access in your application, then you will go for it. Okay. OAuth2 is basically, I don't want to implement my own logic for that. I want to provide the login access for the people based on the third party applications. Then you can go for it.
Okay, Ashok. So JWT is for within the application.
Within the application, token based security.
Okay, not for the third party access.
Yes.
Simone. Hi, Ashok.
Hello.
Am I audible to you?
Yes, sir.
See, the saga design pattern, uh, choreographer and orchestrator. Okay, when we go for choreographer and when we go for orchestrator, is there any specific scenario
Specific
we
scenario
can?
means specific scenario means if your services to be executed independently, if a lot more number of services are involved in the request processing, when the request is getting processed by multiple services, for example, order service is available, then payment service is available, then order fulfill service is available, then inventory service is available, then delivery service available, then tracking service is available. So if you have multiple microservices, more number of microservices are involved in processing the request, then choreography is better because they will work independently based on the events. But if you have just 2 to 3 services to manage the operation, then orchestrator is better because everything will be managed by the orchestrator. Where more number of requests are when the more number of services are increasing in the processing, right? So if tomorrow if I want to add some new service, I need to change the orchestra. Tomorrow if I want to remove one service from the execution flow, I need to change the orchestra. So if the functionality is limited, if it is a small functionality, less number of microservices involved in the processing, then orchestrator is good. From the central point, we can manage everything. If more number of services are involved in managing our request, then going for choreography is better.
Okay. The theoretically it's fine. Can you give any example code for this?
I told you, right? Tomorrow we are going to do practical example on this SAGA pattern. Tomorrow we are going to implement this project. So whatever the diagram you see here, right? So this diagram we are going to implement tomorrow. For that, we are going to set up Apache Kafka in our system. And first we will send a request to create the order. When the order is created, it will publish a message to the topic. When the message is received to the Kafka topic, payment service will listen to that topic and payment process will happen. Once the payment process is completed, it can be failure or it can be successful. Then it will publish a event to the topic. That event will be listened by order fulfill service. Then it will confirm the order or it will cancel the order. This we are going to implement in the tomorrow. Practically, we will.
This is a choreographer, right?
Choreograph, yes.
Okay, as the same way, we will give one more example for the
we can do that.
also.
We can do that.
Okay. Okay, fine. Thank you.
Yeah, hi, sir.
Yeah, hi, Ashok.
Hello.
Ashok, is there any chances that a single service can implement both JWT and OAuth 2?
You can do that, sir. So when generally OAuth 2 is required when your application is having some UI, when you want to provide some third-party access for that, then you will use OAuth. Suppose if your application is only a backend application to communicate with the third-party APIs, then JWT is sufficient. Suppose if your application is having some front-end and backend, for example, IRCTC is available. Okay, so users can directly log into IRCTC from the user interface. And IRCTC is having some backend REST APIs also. Then we can implement both OAuth 2 and JWT in the single project.
Okay. Okay. So, for suppose if there is a series of service, see the request is coming from front end. This is like a middle service. Can we implement in that kind of a service also?
Yes, we can do. Middleware service can be implemented with the JWT. Front end that will be implemented with the OAuth. Third party access, basically.
Hello, sir.
Because some users are not interested to create accounts to use our applications. They want to use their existing accounts in the social media to access our applications. Then we can go for it.
Okay, there was a scenario like a single service has to be both internal and external. In that case, I was asking.
Yeah,
then both we can implement.
Sir, in design patterns, we have a lot of design patterns, right?
Sorry, can you come again, sir? Can you come again, please?
Yeah, I'm audible.
Yes, you are audible now.
Yeah, actually, we have multiple design patterns, right? In our projects, so where do we implement our design patterns?
We'll discuss that, sir. In the project session, I will clarify. So once this syllabus will complete, then in the interview preparation, I will tell you what are the questions they will ask and how to answer that. We will have a separate class for it.
Okay.
Sir, in real life, which is mostly used, sir, for the company project and in mostly choreographer or centralized in real life?
Can you come again, sir? I'm not clear with your question.
In real life, Ashok, sir, in our company project or in real project, which between these two methods, which one is prefer mostly, choreographer or
Sir, mostly people will use choreography based patterns because event based implementation will be done. We have
Okay.
implemented choreography based pattern in our project.
Okay, sir.
Hello, sir.
Yeah, hi.
Sir, how to work on the store procedure in Spring Boot, sir?
@query annotation, sir. How do you call the store procedure by using callable statement, right? You can write @query annotation, native query is equal to true call procedure name. How you will call by using callable statement? Same query you need to write by using @query as a native query. You can do that.
Sir,
Got
I
it.
was asking, what are the design patterns used in your microservice architecture? How can to answer?
You can say that SAGA pattern, you can say that circuit breaker design pattern, and you can say that cache design pattern, Redis cache that we have seen, right? These patterns you can say. Front controller design pattern, filter, or the dispatcher servlet. I will give that answers. So once these pending topics are completed, we will do the interview preparation. At that time, I will explain. Got it?
Hello.
Yeah, hi.
Hello, sir. My question is, sir, I need one mini project, sir, for overall microservices and using Spring Security JW.
Sure.
Like when I want two microservices and API gateway or all that thing.
I have given the requirement also in the Spring Boot. So did you develop that? I have given one stock related microservice application with the requirement.
Stock related.
In the SBMS class only I have given the microservice requirement.
No, sir. Don't know.
Maybe you missed it, sir. I explained that. I have given the requirement to develop with all the topics that we learnt in the microservice architecture as a mini project. I have not implemented that, but I have given the requirement. I have given the task for the people to implement it.
Can you
No,
share
I already
document?
developed three project only. You whatever you given. Three
Are
project.
you in the Spring Boot class or in the JRTP class?
Both, sir. Spring Boot and
If you are
JRT.
in both, in the Spring Boot, I have given that requirement.
Sir, can you share
will
the
say
document?
that
Sir,
I will say-
I request you, sir, one project you can develop for whole microservices using Spring Boot.
Okay.
Okay, thank you.
Good. Fine, guys. Thank you. With this, I'm stopping for today. We'll meet in the tomorrow session. Tomorrow, we will implement the SAGA design pattern by using choreography approach. I will share this diagram for your reference and I will update the notes also. You can refer in the internet. Thank you, guys.